Welcome to this Maths Made Easy video on convex and concave curves. To start with, let's take a look at distinguishing between convex and concave. And we can see a diagram here which we'll use to help us through this. So convex curves curve downwards and concave curves curve upwards. But that doesn't sound particularly mathematical. So let's define this more formally. So when f prime of x, so the second derivative here, is greater than 0, we have a portion of the graph where the gradient is increasing, so the graph is convex at this section. Okay, so the gradient is increasing. So gradient is increasing. So the gradient is increasing. In that case, then this graph is convex at this section. Okay, so convex at this section. Okay, we can see that from our graph here. And just a quick point here, to help distinguish between convex and concave, one thing we can do is, for example, plot 2 points. Okay, so between these 2 points here, if we connect these 2 points, what you'll find for convex curves is that the points that you connect here, the line that they form, is always above the curve. Okay, doesn't matter where we pick. If we were to pick here, for example, if we join these up, again, we can see they're above the curve. And for concave, again, pick 2 points. Let's say those 2 points there. If we connect these 2 points here, the line they form is always under the curve. So with convex, the lines are above the curve, and concave, they're below the curve. And for f prime of x, so the second derivative here being less than 0, well, that tells us the gradient is decreasing. So the gradient is decreasing. What we say then is this is concave at this section. Okay, so concave at this section. Okay, so that gives us everything we need there for distinguishing between convex and concave. Moving on now to take a look at points of inflection. Now, a point of inflection occurs when the curve transitions from convex to concave or vice versa. So we're looking for sections of the graph where f prime of x equals 0. And note here, while all points of inflection have f prime of x equals 0, not all points where f prime of x equals 0 are points of inflection. Okay, so we have to check the curve actually changes from convex to concave or vice versa by seeing what happens on either side of the point. So let's take an example here. Let's say we have f of x. So we have f of x here, which is equal to x cubed minus 3x squared plus 2x plus 1. Well, if we find the first derivative here, so that's f prime of x, well, differentiating term by term, we get 3x squared, we get minus 6x, and finally we just get plus 2 here. Okay, and if we now find the second derivative using our first derivative here, we get f prime of x, that's simply going to be equal to 6x minus 6. So what we're looking for here is f prime of x equals 0. So f prime of x equals 0. So if we set this now equal to 0, so therefore 6x minus 6 equals 0, and we solve for x here, we get 6x equals 6, and therefore x equals 1. Okay, just dividing the left-hand side and the right-hand side by 6. So that tells us f prime of x equals 0 when x equals 1. So therefore, f prime of x is less than 0 for x being less than 1, and f prime of x is greater than 0 for x greater than 1. Okay, so the curve changes from concave to convex at x equals 1, so there is a point of inflection at x equals 1. And just make a quick note here that if there is a point of inflection that is also a stationary point, i.e. f prime of x equals 0, then this is called a stationary point of inflection. So that gives us everything we need there for points of inflection, and that concludes this Maths Made Easy video on convex and concave curves.